It looks like you're setting up SatTrack Radio, a specialized tool for amateur radio satellite tracking. Based on your screenshot, you're currently in the Settings menu. Here is a breakdown of what these configurations do and how they affect your satellite passes. Pass prediction and TLEs. This section determines when the app tells you a satellite is available. Min. LEV. Degree. Currently set to 0. This means the app will notify you the second a satellite crests the horizon. For practical use, you might want to raise this to 5 degrees or 10 degrees to account for trees or buildings in your way. TLE management. You have auto update on and the source set to AMSAT. This is excellent. Two-line elements, TLEs, are the orbital data points used to calculate positions. Since orbits drift, keeping these fresh is vital for accuracy. Antenna specs, link budget override. You've enabled overrides for your hardware. These values help the app calculate if your signal is strong enough to reach the satellite. VHF UHF antenna, dBi. You have specific gains set, 8.90 and 12.00 dBi. These suggest you are using a directional antenna, like a Yagi, radio TXP-WRW, set to 10.0 W. This is a standard power level for portable satellite work, like using an FT-817/818 mentioned in the support section. Quick tips for your setup. Radio connection. You have Auto Connect unchecked. If you are using a Bluetooth or USB interface to control your radio's frequency, Doppler correction, you'll need to enable this or connect manually in the Analysis or Coordinate tabs. Check your location. Since the bottom bar shows JO97 below horizon, make sure your GPS or manual coordinates, under the Location tab, are accurate. If the app thinks you're in the wrong place, the tracking will be off. Save configuration. Don't forget to hit that green button. The app doesn't always auto-save changes made in these text fields. Are you planning to use this for voice, FM, SSB, or digital modes like APRS? Knowing your specific goal can help me fine-tune these settings with you. That looks like a very detailed satellite tracking interface. You're checking a pass for FO29, Fuji Oscar 29, on April 5th, 2026. Based on the pass details section at the bottom, here is a breakdown of what the link budget and margins are telling you. Link quality assessment. The software has flagged this pass as marginal, because your worst case margin is 5.1 decibels. In amateur satellite work, a margin between 5 decibels and 10 decibels is usually considered workable but requires a good antenna system, while anything below 5 decibels, like your LOS edge at 2.7 decibels, is borderline. Key data points. Uplink margin, 5.1 decibels. Your signal reaching the satellite is healthy, but doesn't have a massive amount of extra power. You'll likely be heard fine, but you won't be booming in. Downlink margin, 9.7 decibels. This is quite good. It means the satellite signal reaching your ground station is 9.7 decibels above your noise floor/threshold. You should hear the downlink clearly. FSPL, free space path loss. At 154.7 decibels, that's a lot of signal attenuation over the 2,975 kilometers distance at AOS, acquisition of signal. The challenge, elevation and range. The reason for the marginal score is likely the low elevation of the pass. Max elevation, only 17.6 degrees. Duration, a short 3M18's window. Because the satellite stays low on the horizon, the signal has to travel through more of the Earth's atmosphere and over a much longer physical distance range compared to an overhead pass. Pro tip for this pass. Since the LOS, loss of signal margin, drops to 2.7 decibels, expect the signal to get very fluttery or disappear entirely right as the satellite approaches the horizon, 0.0 degrees elevation. If you are using a handheld Yagi, you'll need to be very precise with your tracking to keep that 5.1 decibels margin. Are you planning to work this pass on SSB or CW? It looks like you're tracking JO97, also known as CAS-4B, a Chinese amateur radio satellite. This screen shows some pretty sophisticated calibration data, likely from a specialized tracking app using AI to compensate for frequency shifts. Here is a breakdown of what these statistics mean for your next contact. The intelligent choice, active frequency. The app is recommending specific frequencies to account for the Doppler effect and internal hardware drift. Uplink TX 435.10767 MHz. This is where you should transmit. It has a calculated offset of -2.36 kHz from the nominal center. Downlink RX 145.865197 MHz. This is where you should listen. Source. It's using an LSTM, long short-term memory, AI prediction, which means it's looking at your past sync history to predict exactly where the satellite's oscillator is today. Statistical analysis. Mean. These are the average frequencies the satellite has been found at over your last 20 syncs. STD Dev, standard deviation. The uplink has a deviation of plus or minus 1.389 kHz. This suggests the satellite's 70 cm transponder drifts a bit more than the 2 meters downlink, which is common due to higher frequency thermal sensitivity. 95% CI, confidence interval. The AI is 95% sure that the true frequency is within plus or minus 0.309 kHz of the prediction. That's a very tight window, great for SSB or CW work. Frequency drift and stability. Drift prediction. The satellite is drifting incredibly slowly, minus 0.044 kHz per day on uplink. Stability. Labeled as extremely stable. This is good news. It means once you dial it in, you won't have to chase the signal much across the pass, other than for normal Doppler shift. R-squared, coefficient of determination. At 12.0%, the linear trend isn't very strong, likely because the drift is so small it's being lost in the noise of daily temperature fluctuations. Sync history observations. Looking at your table, you have recent syncs from March 30th, 2026. Notice how the uplink, megahertz, changes slightly as the elevation drops from 9.5 degrees to 5.4 degrees. The downlink stays rock solid at 145.865200 MHz. This suggests the satellite's own down conversion crystal is very high quality, or the app has already perfectly corrected the downlink side. Pro tip. Since JO97 is currently below horizon according to your status bar, keep these intelligent choice numbers ready for its next pass. The quality good indicator suggests your previous tracking data is reliable enough to trust the AI's tuning. That looks like a screenshot from a satellite tracking application, likely something like gPredict or a similar ham radio satellite tracker. It's a great tool for timing when to step outside with an antenna or a telescope. Here is a breakdown of what you are looking at. 1. Sky map, top circular plot. This is a polar projection of the sky directly above your current location. Based on the image provided and the app name SatTrack Radio, developed by 9G5AR, a licensed radio amateur in Ghana, you are looking at a specialized tool designed for satellite tracking and amateur radio operations. Here is a breakdown of what the different sections of the screen are telling you. 1. Sky map, top section. This is a polar plot showing the path a satellite will take across your local sky. Satellite being tracked, JO97, Jordan Oscar 97, JY1 SAT. The blue line represents the predicted pass. It starts in the north, 941, reaches its highest point near the center at 946, and sets in the south, 952. The rings. These indicate elevation. The center is 90 to the power of circ, directly overhead, while the outer ring is 0 to the power of circ, the horizon. 2. Live pass data, green bar. This summarizes the upcoming window of opportunity to communicate with the satellite. Next, 941. The time it rises above the horizon. Max L, 70.3 degrees. This is a high pass. The higher the elevation, the better the signal usually is because there are fewer obstacles, like buildings or trees. 11 meters. You have an 11-minute window to use the satellite before it disappears. 3. Ground track, bottom section. This is a Mercator projection, world map, showing where the satellites are currently located over the Earth's surface. Yellow sun. screenshot you provided shows the SatTrack radio app, developed by 9G5AR, tracking the JO97 satellite, also known as JY1-SAT. At the time of the screenshot, the satellite was below the horizon, elevation minus 27.6 degrees, with the next pass scheduled for April 4th, 9:41 Coordinated Universal Time. JO97, JY1-SAT, communication details. JO97